All right, so we're looking at some trigonometric ratios today. We talked about right triangle and identifying sides in the previous video, and it's important that you guys know what the opposite side is and the adjacent side and the hypotenuse. So if you don't remember that, you might want to go back and make sure you remember that, okay? So trigonometric ratios, we're going to look at, we call a field called trigonometry. Trigonometry is dealing with triangles and their side lengths and the angle measurements. So we're going to look at the distance from like A to B, C to B, A to D. So their side lengths and then the measure of these angles and what happens on triangles. And what we're going to focus on is we're going to really focus on, whoops, let's have the right thing here. We're going to focus on right triangles. Okay, so again, triangles that has a 90-degree, struggling here. Really struggling here. Again, triangles that, you probably should focus on one thing at a time here. Triangles that have a 90-degree with them. So again, trigonometry is the relationship between side lengths and angle measurements. And we're going to look at right triangles. So let me give you an example, and we'll come back to this slide. So if I had this triangle here, and I've got everything measured here, this angle T is 53.13, this is 90, this is 63.87, I've got this length is like 4, let's just say it's feet, okay? This is 5 feet, and this is 3 feet. Again, it's like if I was to take a tape measure and measure from T to M, so on and so forth. This is going to occur all the time in this case. This 3, 4, 5, the angles will always be that in this 3, 4, 5 triangle. It always occurs. Whatever the angle is, there's going to be something that's going on with the sides. Now, it's not always going to be 4, but what is going to happen is there's going to be a ratio or a relationship between a couple sides and its angle that we have. And that's what we call again, trigonometry here. There are 3 trigonometric ratios that we're going to talk about. We actually name them, and we'll get into those here in just a second. But we're going to look at their side lengths. What we're going to do is we're going to look at a side length that is the opposite side divided by the hypotenuse side. So that would be taking the distance of the opposite side and dividing it by the hypotenuse side. We're going to take the adjacent side and divide it by the hypotenuse. And then we're also going to take the opposite and divide it by the adjacent. Those are the 3 ratios we're going to really focus on. And we're going to group these all into certain groups. And we're going to actually give them names. One of them is called sine. One of them is called cosine, and the third one is called tangent. Okay, so sine, cosine, and tangent. We're going to use these a ton. And these match up with these ratios here. So let me define them specifically right now, okay? So let's just start with the sine. And we're just gonna use the first 3 letters. I'm just gonna shorthand it, sine, cos, and tan for this. If I take the sine of an angle, so we're gonna use this little symbol for angle. So this means angle here, this little 0 with the dash through, it's a Greek letter called theta. So we're gonna take the sine of an angle is always gonna be equal to the opposite distance, the opposite side of that angle, divided by the hypotenuse of that triangle. So if you see sine of an angle, that means we need the opposite of that angle we're talking about divided by the hypotenuse. So that's how we define sine. Cosine, so cosine of an angle is going to be equal to the adjacent over the hypotenuse. So again, every single time, the cosine of whatever angle we're talking about is always the same as the ratio of the adjacent over the hypotenuse. And then the last one is tangent of an angle is going to be equal to the opposite divided by the adjacent. These rules are always true. You want to like probably memorize these. And this deals with right triangles as well. Make sure you understand this is a right triangle deal here. So again, the sine of an angle is opposite over a hypotenuse of that angle. The cosine of an angle is equal to the adjacent over the hypotenuse, and the tangent of an angle is equal to the opposite over the adjacent. Okay. So if we go back to this triangle right here, and let's just say I say sine of t. Okay. Well, sine of t, that's 53, right? So, but we're not going to put that. The sine of t is just going to be equal to the opposite side divided by the hypotenuse, because sine, again, sine is opposite over hypotenuse. So what is opposite of t? Opposite of t is 4, and the hypotenuse is 5. So this would be equivalent to 4 over 5, okay? So what that means, guys, is if I took a calculator, and you guys have probably all seen on a calculator like the sin, the cos, and the tan before. You've seen all that before. If I go and I just type in sine of 53.13 into my calculator, again, sine of 53, whoops, turn on, sine of 53.13, and I type that in, that is going to give me 0.8, okay? Well, that gives me 0.8, but guys, what is 4 over 5 equal to? If you go 4 divided by 5, that's 0.8. So see how that angle is always going to give me that same ratio, okay? So what I really, that's kind of to help you kind of understand what we're doing here. Again, whenever you have that certain degree measurement, it's going to give you a certain ratio between those two sides. That opposite side, whatever it is, in this case it's 4 and the hypotenuse is 5, but I mean it could be something else, but the ratio when you divide that opposite side by the hypotenuse size, it's always going to give you 0.8. It's a definition. So these rules right here are like definitions. The sine of an angle is always the opposite, always equivalent to the opposite over the hypotenuse side when you divide those two. The cosine's always equal to the adjacent over the hypotenuse. Okay. Again, so we can go keep doing this. Like, let's just say I don't know the angle measurements, but let's say I went, hey, what is the cosine of t? Well, the cosine of t, again, is the adjacent. Again, if you look at previous sine, adjacent over hypotenuse, you want to memorize those. So what is adjacent to t? Adjacent to t is 3, and the hypotenuse is 5. So this would be 3 over 5, or, again, that would be 0.6. Okay? If I did tangent of t, tangent of t is the opposite side over the adjacent side. So that would be 4 over 3, or, again, that's going to be equivalent to 1.3 repeating, okay? And so that's always going to be that case. Now we know what t is. T is 53.13. Like, that's not a mystery to us. We already know that's what that is. Let's say we went the sine of m. Sine of m, again, that's not going to be the same as sine as t, because now I'm down here, right? I'm dealing with a different angle here. The sine of m is still the opposite of m. The opposite of m is now 3, and the hypotenuse is 5. So this is going to be 3 over 5. If I went the cosine of m, well, what's the adjacent side of m? 4, and the hypotenuse is 5, so 4 over 5. And if I went tangent of m, that's just going to be opposite of m, which is 3, and the adjacent to m, which is 4, so that'd be 3 over 4. Okay? So that hopefully gives you kind of an understanding of what we're doing. Again, triangles always follow these patterns. Always, always, always. Pretty useful that way. So let's just go here. Let's say we've got ourselves a triangle here. So this is what I want you guys to be able to do here. Let's just be generic here, A, B, and C here. And let's say I've got this side as 5 and this side at 12. I know this isn't the scale, that side's 3. I want you to be able to say, okay, if I ask you what is sine of A, again, I don't know what this measurement is, right? But what if I ask you what the sine of A is? Well, you know, sine of any angle is opposite of that angle over the hypotenuse. So what's the opposite of A? The opposite of A is 12. So this is going to be equal to 12 over 13. That would be my answer there. Okay, let's say I went, what is the cosine of C? Well, again, I would go to C, and I know that the cosine's ratio is the adjacent over the hypotenuse. So I say, okay, what's the adjacent to C? There it is. So we go 12 over the hypotenuse is 13. It just happens to be the same ratio, but we have different angles, okay? If I went the sine of C, now I'm here at C, and I've got to go opposite of C, which is 5. And then 13 is my hypotenuse. That's my ratio. And you can do this all day. I mean, it's the same thing. So tangent of A, if I go tangent of A, the ratio for tangent is opposite over adjacent. So opposite of A is 12, adjacent is 5, so this would be 12 over 5. Okay? Again, you can keep going and keep going. I want you to be able to write these ratios down. This is part of your guys' skills that I need you to be able to do. Okay? The other thing I want you to be able to do is if I ask you, hey, what is the sine of 33 degrees? I want you to be able to do that. And the only way we're going to be able to do that, 30 years ago, they looked at the back of the textbook and they had charts for this, but I just want you to be able to use this on a calculator. Literally, all you have to do is just type in sine 33, hit enter, and it will give you the ratio. Because this is 0.545 if you go that far out. If I have to round, this is an irrational number. That's what I'm looking for these. It's not going to put it as a fraction per se. It's just going to put it as that. So you do need to do that. So if I went, let's say I went cosine of, let's say 60, I'm just going to type in cosine of 60. That's 0.5. Or that one does give me a rational number. 1/2 would be great. So I want you to be able to type that in. Okay. This, when you do the sine or cosine, if you do a trig function of an angle, it's going to give you the ratio of that opposite over adjacent, but it'll give it to you as a decimal and not as a fraction. Okay. So that's again, given that, I want you to find those ratios. The other thing I want you to be able to do, every function has an inverse, which means it does the opposite. So if I take the sine of an angle, well, if I want to do the inverse, let's say I do the inverse sine, the inverse functions are these -1, so cosine, -1, tangent, -1. All it is just doing the inverse. If I ever do that, then I need to take a ratio. So if I went 0.545 and I said, what's the inverse sine of that? It will give me my angle measurement, which when I type that in, again, I want you just to use your calculator. There's the inverse sine's right above the sine for that. You're just going to type in inverse sine of 0.545, and when I do that, guess what? You should get 33 out, or something really close, which now it's giving you an angle. So see how inverses give you angles. Again, if I go inverse sine of 0.5, sorry, not that. We shouldn't say equals. We should have parentheses around there. So I do that. I'm going to get an angle out. And when I type that in, sure enough, I get 60. Okay? So I want you to be able to do the inverses. Whenever you use the inverse, it's going to give you an angle measurement. Whenever you use the angle, it's going to give you the ratio. Okay? So just be able to type those in. Again, you see the -1. Those should be ratios instead. Okay? So let's say I did inverse tangent of 0.75. Let's go there. That's a good ratio. So inverse tangent 0.75. For that one, I get an angle of 36.87. And most of the time, you guys are going to have to round and get some, but that would be an angle measurement. Okay? So again, I expect you to be able to write ratios. If we don't have angles, we just basic stuff here, and then use your calculators to find either ratios or to find angle measurements. All right, Math Mo with Mummy out.